So now let's move inside from the magnetic field and take a look at the atmosphere. So our atmosphere is mostly composed of nitrogen and oxygen. As you can see here in this pie chart, mostly nitrogen, 78%, and then about close to 21% oxygen, and then just a very small sliver is everything else. The remaining gases tend to be argon, carbon dioxide, and neon, which as we move on in the semester, right, we're going to talk about this guy right here, because that's not a friendly one. The atmosphere itself thins away from Earth. The closer you are to Earth, the thicker it is. The higher up you go, the thinner it is. If you've ever gone to the mountains, you've probably experienced this. If you go up in the mountains, you might notice that it's a little bit tough to breathe up there. And that's because the atmosphere is much thinner. So our atmosphere has layers, and we're going to talk about those in a minute, and they have very distinct characteristics. They're mostly going to be defined from each other based on temperature differences, because that's the easiest, but we can see that there's pressure differences, density, and moisture. So like I said, the atmosphere itself is more dense the closer to Earth you are, and that's just due to gravitational pull, right? The closer you are to Earth, the higher the gravitational pull. The further away from you are from Earth, right, the less the gravity. So when we talk about atmospheric pressure, you may have seen that if you watch the weather on the news, is quite literally, right, if you're standing here on the Earth's surface, atmospheric pressure is the weight of all of the atmosphere pushing down on your shoulders. It is about 14.7 pounds per square inch. So that's what you have pushing down on you all the time, right? So see, you're constantly working out, right? You've got all this atmosphere pushing down on you. So of course, the higher up we go, the pressure decreases, right? Because if I was standing up here, well, not standing, flying, right, I'd have less on top of me. So density is also going to decrease, and our oxygen content decreases as well. So let's take a look at the layers. So we have four main layers to the atmosphere, and they're separated by a pause. So the pause is just kind of the boundary. So if we start down here at Earth's surface, if you were to fly upwards, the first layer you would go through is the troposphere. This is the lower mixing layer. This is where all of the weather happens, all of the hurricanes, all of the thunderstorms, all of the blizzards. It all happens right here in this layer. As we move upwards, the temperature decreases, so it gets colder. Now, after we cross that boundary, our next layer is the stratosphere. There's no mixing here. So because of that no mixing, what we see is our temperature actually gets hotter as we go upwards. So you can see that that temperature is defining the differences between those layers. The next layer is the mesosphere. The mesosphere, again, you can see the temperature decreases upwards, right? So we have a flip-flop again. And then our thermosphere, by its name, heat, right, is our outermost layer, and the temperature increases. So again, really the easiest way to remember this is it's due to our temperature changes, right? Troposphere, temperature decreases, stratosphere, temperature increases, mesosphere, temperature decreases, and then the thermosphere, it increases. So, the Earth itself, right, there are several spheres to our planet. As we just talked about, the atmosphere is the gaseous envelope that surrounds the Earth. The hydrosphere is all of the liquid water, okay, so that's both the salt water and the fresh water. The cryosphere is the frozen part, so our glaciers, right, you can see here, right, the glacier up at the top, and that's part of the cryosphere. The biosphere is all of the living and once living, so that includes fossils. And the lithosphere is the solid Earth. So for this semester, we're really going to be mostly concentrated on the lithosphere. Right? We're really going to pay a lot more attention to what's going on with the solid Earth. But you do need to realize that all of these systems interact with each other. Clearly, the atmosphere interacts with the biosphere. Right? It's raining today. Right? That definitely affects the biosphere. Okay? So Earth is in what we call the habitable zone in our solar system. Right? If we were a little bit closer, a little further away, we probably wouldn't be here. Now, what's interesting about this is we're learning that this isn't necessarily true. There are other objects in our solar system that have liquid water, namely some of the moons that go around Jupiter. Right? They actually have liquid water. Now, we don't know about the life part yet. However, we do see liquid water. So those are some pretty cool implications there. Now, most of the dry land itself is pretty close to sea level. It's within 1 kilometer of sea level. We don't see too many extremes up in the high or up in the low. However, the highs are what we call mountains, and we're going to see the lows are what we call trenches, and that's a geology term, so we're going to talk more about that. But our two dominant levels definitely reflect what we call the continent and the ocean, right? Clearly, the continent is much higher than the ocean.